Hello, my dear student, Mr. Wael, teacher of chemistry at STEM School, with you. Our session today about Vesper theory. First, we will discuss the differentiate between polar and non-polar compounds. In this slide, as we see, in the right, there is non-polar molecules, and in the left, there is polar molecules. First, we will recognize that nonpolar molecules like diatomic molecules like N2, O2, Cl2, F2, H2, and inert gas or noble gas like He, NeAr, Xe. Also, we will consider that organic compounds like hydrocarbons, CH4 methane or C2H6 ethane or C2H4 ethene. Yes, these all are non-molecules. Okay. The second step is we notice the geometry, like in CF4, as we saw that CF cancelled the against CF. On the other hand, CF in up cancelled CF in down. So this compound is nonpolar because the forces or the bonds is cancel each other. So in SBr6 in the same way nonpolar, but BH3 we notice that two of bonds come over or gain the third. So BH3 is polar. BCl5 also it polar. CO2, oh yes, it's nonpolar because CO against CO the other. Okay, this is nonpolar compound as we see. Let's discuss the polar molecules. First, the bond between H with N or with O or with F, we call them NOF. They consist a polar molecule. Also H2O with water or NH3, ammonia or HF. Also the organic compound like the compound contain OH, we call it alcohol, and which contain NH2 amino compounds or COOH called carboxyl acid. They all polar. Also, we can show the COS. We note that CS electronegativity of S is 2.5 and C is 2.5. So the differentiate is 0. So is non-polar. But on the other hand, C 2.5 and O 3.5. So the negativity or the differentiate is 1. Oh, we must know that the differentiate at least is 0.5 to be polar in differentiate. So it's a polar bond. So in SO2 we saw that is not cancelling, so it is a polar compound. Also in NH3 is polar compound as we see. Let's discuss Vesper theory. as we see that visible theory is related with valence shell electron pair repulsion theory, a model of describing the shapes of molecules whose main postulate in that the structure around a given atom in A is determined by minimizing the electron pair repulsion. Therefore, the electrons and elements bonded to the central atom want to be as far apart as possible. Okay, as we see in the next slide, visible steps. First, draw the Lewis structure for the molecule. 2. Count the total number of things that are around the central atom to determine the electron pair geometry. Third, imagine that the lone pairs of electrons are invisible and describe the molecule shape. Okay, we will see table illustrates this characteristics. Summary visible and hybridization table. First, electron domain. We can replace it by number of bonds. First, 2 means that there is 2 electron or 2 bonds in the around the central atom. It composed a linear shape, and the angle will be 180. Type of hybridization is sp. In case of non-lone pair or 1 or 2, there is no any shape or any other shape. When we find 3 electron domains or 3 bonds, we call the shape is or the geometry here is triangle planar. The angle will be 120. The kind of hybridization is sp2. When we find non-lone pair, we can consider that it trigonal planar. When we find one lone pair is pin. It little bit differentiate in the shape because of found lone pair. It decrease the angle little. Okay. When we find 4 electron domains or 4 bonds in the molecule, we called it in geometry tetrahedral. The angle is 109.5. The kind of hybridization is sp3. In we can say that shape is tetrahedral with where is no when there is no lone pair. When we find one lone pair in this structure, we called it trigonal pyramidal. When we find 2 lone pair, we can call it bent from trigonal pyramidal. When we find 5 electron domains or 5 bonds, we called it trigonal pyramidal or trigonal bipyramidal. There is a difference between trigonal pyramidal and trigonal bipyramidal. The angles will be two kinds. One kind is 90 degree and the second kind 120 degree. The kind of hybridization is sp3d. When we can't find lone pair, we describe it as diagonal bipyramidal or pyramidal. When we find one lone pair, we called it seesaw. When we find two lone pair is T-sharp or T-shaped. Last, when we find six electron domain, we called it octahedral. The bonds is 90. The kind of hybridization is B3, D2, zero lone pair is octahedral. When we find one lone pair is square pyramidal. When we find two pair is square plane. Okay.